All right, hey you guys, we always start every day off with an entry task, and so we'll keep on doing the same. I'm going to try and keep things as close to the classroom as possible. So why don't you go ahead and try these two problems from our last video. All right, don't forget, you can always pause the camera and work on this. I'm just going to wait 5 seconds and then get started. So for the first one, I would look at this and say, well, this is n minus 5. And now I got to subtract 1, so the next one down would be n minus 6, and then n minus 7, and that'll keep on going. In the denominator, I'm going to start at n minus 6, subtract 1 from that, you get n minus 7, and then you keep on going. And again, we just want to get to the point where we can see that the pattern the rest of the way down is going to be the same. Then we can go ahead and cancel those. Here go the n minus 7s and then everything from that point on. And all I'm left with is an n minus 5 in the numerator. So there's my answer. All right, for the second one, this says the summation for I equals 5 to 7 of 2i plus I squared. So I'm going to take a 5 and plug that in first. So when I do that, 2 times 5 is 10, plus 5 squared, that's 25. And then we're going to let I equal 6. So I plug that in and I'm going to get 12 plus 36. And then we'll let I equal 7, and that's where we'll stop. So I'm going to get 2 times 7 is 14, plus 7 squared, that's 49. And so now I just need to add these up and then add those three answers together. So 35 plus 48 plus 63. Oops. And so then if I add those three numbers, I've got 35 plus 48 plus 63. And I get 46. I know you guys can't see my calculator. I'm just assuming that you've got your calculator and you're doing this right along with me. And so as long as our answers match up at the end, we know we're doing okay. All right, so for today, we want to talk about something called an arithmetic sequence. And this is just a sequence of numbers where you always add. That's real important. We're adding numbers. And what we're doing is we're going to add the same value each time. We're going to call it the D value to get the next term. So when you look at this example here, I've got a sequence of numbers. The word sequence means it's just a list. Okay, we're not doing anything with them. It's just a list that's sitting there. And so when you look at this, you can see that I'm adding 3 each time to get to the next term. So the next term after this would be what? 16. And then we get 19 and so on. And that sequence just keeps on going forever. That's what the ... means. And what we're going to try to do is we're going to try and find the nth term. So this kind of goes back to that elementary school kid again. You know, the teacher thought he was being slick one day and he said, hey, I want you guys to count by 3s and I want you to find the 148th term. And of course everybody would make mistakes adding those numbers together. But the little kid, he looked at this and he said, well, this is my first term, this is my second, this is the third and fourth. And all I'm doing is adding 3 each time. So what I'm going to do is I'm going to start with 4 and I'm going to add 3s. But the question is, how many do I want to add? Well, let's see. We added 1 3 to get to the second term. If you start at 4, you have to add 2 3s to get to the third term. And to get to the fourth term, I had to add 1 2 3 3s. Well, the number of 3s that you're adding is always 1 less than the term that you're on. So this little kid figured out that all you have to do is multiply by n minus 1. So you want me to find the 148th term? Okay, I'm going to start with 4. I can see that I'm adding 3 each time. And I want to add 1 less than the term I'm on. So I'm going to add 147 3's. And so if I do that, let's see, if I grab my calculator, 3 times 147, I get 441. So if I add that to this, I've got 445. And so now this little kid is up at the teacher's desk again. Teacher, I got the answer. And he always found easy ways to do this, even when the teacher was trying to give them busy work. So let's see if we can come up with a generic formula for this. If I ask you to find the nth term, then what we're really saying is we want a sub n. We use a because it's an arithmetic sequence. And here we'd say a sub 148 equals 445. And so this little kid said, I'm just going to start with the first term, so that would be a sub 1. I'm going to add some number, which, here our 3 is the d value. And I'm going to multiply that number that I'm adding times n minus 1. Whatever term I'm looking for, this is 1 less than that. And there's the formula that we want to work with. Thanks to this elementary school kid who figured that out for us. All right, so here's a different problem. We've got our arithmetic sequence. We know it's arithmetic because when I look at it, I'm always adding the same number to get to the next term. And so our d value here would be 7. So d equals 7, and they're asking us to find the 42nd term. So if I use this kid's formula, a sub 42, that'd be my 42nd term in the arithmetic sequence. It's going to equal my first term, which was 2, plus the amount that I'm adding, that's 7. And I'm looking for the 42nd term, so I need to multiply that by 1 less, which would be 41. And so what I have here is 2 plus, this would be 287. Add those together, and you get 289. There's our 42nd term. All right, so you guys try this one. Our first term is 7.5, and that's okay. We can have decimals when we do this. The amount that we're adding each time is 2.5. That's our d value. They're not giving us the actual sequence. They're just telling us the first term and what we're adding and asking us to use that to find the 35th term. Go ahead and give it a shot. All right, so using the formula, a sub 35 is going to be the first term, which is 7.5, plus 2.5. And I want to add 1 less than the term I'm looking for, or multiply by 1 less. So 34. And so if I punch that into my calculator, I've got 7.5 plus 2.5 times 34. And 92.5, that's our answer. All right, so here's another problem. It's really the same problem, it's just being asked in a different way. Right here, okay, our first term is 15. We look over this and it's, oh my gosh, what are they trying to say? Well, this k plus 1, and k is the same as the n value, okay? So what that means is the next term after this one, you get it by adding 4. So the next term equals the one you're on plus 4. That's the way we want to read that. And so really, they're telling us right here, this is our d value. So see if you can finish this one up. All right, using our same formula, we're looking for the 52nd term, so a sub 52 is equal to the first term, which is 15, plus, we can see we're adding 4 each time to get to the next term, and we're multiplying that by 1 less, so 51. So I've got 15 plus 204. Add those together and you get 219. There. All right, so this teacher was determined that he was going to stump this elementary school kid who apparently was too smart for his own britches. And so the teacher came up with a good idea. He said, not only am I going to ask you to find the 52nd term, but now I want you to add them all together. So you're going to start at 15, you're going to count by 4s, and we're going to add up the first 52 terms. Well, the little kid sat there and thought about it, and he said, that's not any different than adding 1 to 100. You add the first plus the last, and then you multiply it by the number of pairs. So he said to himself, he had these 2 steps. I'm going to add the first to the last, and then we're going to multiply by the number of pairs. So he came up with a formula that looked like this. The sum equals the first term, we'll call it a sub 1, plus the last term, we'll call it a sub n. In this problem, a sub 52 happened to be the last one. And then what I want to do is I want to multiply it by the number of pairs, which is just your n value divided by 2. And so did the teacher stump the little kid? No. He just gave the kid one more formula to put in a book and have his name attached to. So let's try a couple problems using this new formula. We've got an arithmetic sequence. I can see that I'm adding 4 each time. Remember, you always have to add the same number. And they want us to find the sum of the first 35 terms. Well, using our formula, we would say that the sum is going to equal the first term, which is 23, plus the last term. I don't know the last term yet, but we know how to find this out. That's what we've done the last 3 problems. And then I'm going to multiply it by 35 over 2. Now we're going to have to talk about this. When you have an odd number, do you really get an even number of pairs, and how does that work out? We'll look at that in just a minute. But first, I need to go find the last term. So a sub 35 is going to equal the first term, which is 23, plus we're adding 4 to get to each term, and I want to multiply that by 1 less than the term I'm looking for. So 34. So I've got 23 plus 120 plus 16, that would be 136. Add those together, you would get 159. There's my last term, and that needs to go right here. So if I add those 2 together, I'm going to get, let's see, what is that? 170, 182 times 35 over 2. And so we'll do that in the calculator. I've got 182 times 35 divided by 2 is 17.5. So I'll just multiply by that. And I've got 3,185. There's the sum of the first 35 terms. So we were going to talk about what happens if you have an odd number of terms. So here's 5 terms. I can see that these 2 would make a pair. They add up to 32. These 2 make a pair. They add up to 32. And then it's like that one oddball in the middle, I've got half of a pair. So when I add the first to the last, and then I multiply that by the number of terms divided by 2, what we're saying is I've got 2.5 pairs. I've got this pair and this pair. They all add to 32, and that's half of 32, so it's like half a pair. So this formula works even with an odd number of terms. All right, you guys go ahead and try this one. So I guess the first thing that we should notice here is I'm not adding a number each time, I'm subtracting a number. We're subtracting 3 to get to the next term. Well, subtracting really is adding something, it's just that we're adding a negative number. So that means that our D value is going to be a negative 3. That's what I'm adding each time to get to the next term. So we're trying to add the first 30 terms. First I want to figure out what that 30th term is, the last term. So A sub 30 is going to equal the first term, which is 40, plus D, except my D value is negative, so minus 3, times 1 less. And so what I get is 40 minus, what is that, 87? And if I subtract those, I get a negative 47. So that's my last term. So now I'm going to say that the sum is equal to the first plus the last. So I'm adding a negative, so minus 47. And my number of pairs is going to be 30 over 2. So really what I have here is a negative 7 times 15, which is a negative 105. There's the sum of the first 30 terms. Now you might look at that and go, well, wait a minute, how does that happen? How do we get a negative value when we're adding a bunch of positive numbers? Well, we're subtracting 3, so eventually these numbers get smaller, smaller, and smaller. They'll eventually work their way into negative numbers, and those negative numbers will cancel out the positive ones, and in the end we just have more negative than we do positive. All right, that's what we have for today. And so here's our next assignment. So this is going to be number C2. So next week is spring break. We're already on break, right? So yeah, we're told just carry forward just like normal. If your family's going somewhere, which probably not many of us are, you know, we're supposed to be staying at home. But you know, the videos are online. You can get them anywhere, or take care of them when you get back from wherever you're going. You know, whatever. But I will do 2 more videos next week. I will do them on Tuesday and Thursday, just like I did this week. All right, you guys take care. Be safe.